Alright, so we are done with the user story. We got all the business requirements in place. We agreed on a user interface for our feature. So what's the next question? The next phase? You got it right. Estimations. You're gonna find yourself in a sprint planning meeting with the project manager and the product owner, and we're supposed to start the implementation of this feature in this following sprint. So the PO is going to be asking you how long is it going to take. It's going to ask you for an estimation. An estimation is basically your best guess of how long and the effort that the feature is going to take you to implement. So in many companies, they tend to use estimation mechanisms like the Fibonacci story point estimation, but in my experience, these methods never actually worked. Fibonacci is just a numeric tag that you add to a user story that shows the effort it would take to implement this feature compared to another well-known feature that has similar complexity. There are several problems with this kind of mechanisms. First, all features are different from one another. It's very hard to be accurate in saying that this feature is going to take me the same effort as some other feature. The second problem is that for medium to large features, the number starts to go up. So if we have a 1 or a 2 or a 3 story point for a feature, you might be getting it right. But if you start going up and you have an 8 or a 13 in the Fibonacci scale, then this estimation starts to become a really big guess. A third problem is that effort does not correlate to time. But in the end, the product manager or the product owner, they want to know how long it's going to take to implement. So at some point, you need to correlate your feature effort with time. If you agreed on a 1 sprint implementation time and it took you 3 months because you had a really bad estimation, then this is not going to work for anybody. So before you reply to the PO with an estimation with some story points or whatever method you're using in your project, I'm going to show you what actually works for me to give your best accurate response of how long this feature implementation is going to take. Let's go back to our dependency diagram of the ISS Tracker app, where we can see all the different modules and components that integrate our application. And there is a reason why I created this dependency diagram. It helps me have a mental image of how the application is architected. So if I wanted to add a new feature, this diagram is going to help me understand in which of the module or modules I'm going to have to be focusing on. Now let's come back to our feature that we want to implement. We know what we have to do because we agreed on a user interface and we understand the requirements. And now in this new phase, the question that we have to be asking ourselves is, how are we going to implement it? Since this is a UI feature, then the view controllers and the view models sound like a good starting point. If we focus on the modules we are interested in and their dependencies, we can zoom in. So we have the view controllers depending on external frameworks like Google Maps and UIKit. Then the view controllers both depend on the ISS Tracker view model, and the ISS Tracker view model depends on our core interface, the ISS Tracker Position Loader. Remember that we are senior developers and that we follow the solid principles and clean architecture. One of the main principles is the open for extension, closed for modification. So our objective is to try to implement this new feature without modifying what already exists in our app. Instead, we want to extend the functionality. Also, we have agreed within the team that we want to stop implementing new screens and UI using UIKit in iOS. Instead, we want to be using the new Swift UI framework for all the new screens. These are all technical decisions that you have to take within the team that have nothing to do with the project manager or the product owner, that will guarantee maintainability and scalability in the future. Okay, so let's start architecting. We're going to have new views. So we're going to have one view for the activity indicator. and we can have another view for the error. And we have agreed that both views are going to be implemented using SwiftUI. But since our navigation is still done using navigation controllers, we're going to be adding these SwiftUI views using a hosting controller, and the same with our error view. Then we're going to have a view model as well for each of the new views. Our views are going to depend on our view model. And now it's a good time to go back to our code and check the best design patterns we can choose to make our view models behave the way we want them to. If we dive into our ISS tracker view model, we will see that in our update ISS position method, we call the ISS tracker loader method with a completion handler. And in our completion handler, we switch over the result and we have a success case and an error case. So this seems to be exactly what we want. We want a place where we want to start loading and show the activity indicator, and our completion is going to tell us if it's a success to stop animating the activity indicator, or the error to display the error view with the last updated timestamp label. Now again, since we are senior developers and we don't want to be modifying this code, which already works, we have to find a different way to achieve this. Luckily, the ISS tracker loader is a variable of type ISS tracker position loader, and this interface is exactly what we want. The strategy is going to be to use decorators, one for the activity indicator and one for the error view, which will extend the functionality of the ISS tracker position loader. So coming back to our diagram, we're going to create an activity indicator position loader decorator, as well as a position loadable error decorator, and we'll make them conform to the ISS position loader interface. Also, they will be holding instances of their respective view models, and that's going to be our strategy to extend the functionality without modifying the current ISS tracker view model or the current view controllers. So there we have it. Of course, during the implementation, we're going to find out if we need some other component that we are not seeing at the moment, but if we do need to add an extra component, it's going to be a minor add-on and it's not going to break our entire architecture. Cool, so now we have a plan on how we are going to implement our feature. We have two new SwiftUI views, plus two view models for each of the views, and two decorators that conform to the ISS tracker position loader interface that we already have. And now estimating our feature becomes much simpler. We have our feature segmented into smaller components that are super easy to estimate. We can even picture ourselves how to break down the feature into smaller sub-features that we can implement separately. For example, we could implement the activity indicator view model alongside with its view as a sub-feature. Then we could implement the error view model alongside with the error view as another sub-feature. Then we could have the decorators separated as well. And finally, we could have all the composition of all our sub-features into the app to bring the feature to production. You can even create tickets in your project management tool like Jira with each of the sub-features to track your progress and have a much more accurate estimation for each of them. So now is when you go back to your product owner or project manager and say, I'm in conditions of estimating the feature. I have analyzed how we're going to implement it, and I have created sub-features that will guide me to the completion of the entire feature. So to summarize this video, before you give some random estimation when they ask you how long a feature is going to take, tell them that you need to take your time to come up with an architectural design and a dependency diagram like I just showed you. that will give you a much better idea on how to break down the feature into smaller parts. Remember that inaccurate estimations will not help anyone in the team, so it's much better to step back, not being afraid to tell management that you need time for your estimation, and then come back with a proper answer. As a bonus, these diagrams help as documentation for your feature for other teammates to understand your implementation. If you liked this idea, let me know in the comments, give it a thumbs up, and see you in the next one for the implementation of our feature.